Hey guys, today we're going to start talking about Chapter 2, specifically Section 1, 2.1, which is Use Inductive Reasoning. I have posted these note-taking guide in Schoology, so hit pause if you would like to and go print it out. If you don't want to print it out, then just write these nice and neatly in your notebook, and you can always refer back to the note-taking guide on Schoology. All right, so we're going to write down a few definitions. So I apologize for my wonderful handwriting here. I will post my handwritten stuff later. So a conjecture is an unproven statement based on observations. What that means is in math, when you start doing problems of the same type over and over and over again, in your mind, you're starting to think about patterns that you may see. And you might be like, ooh, this might be true for all the cases. That would be a conjecture. You are seeing a pattern and you are coming up with a rule in your mind that may be true, maybe not, but right now you're starting to see it happening over and over again. You're starting to see a pattern. So, inductive reasoning, the process of finding a pattern and then writing a conjecture about it. And finally, a counterexample. All you need is one example to prove a conjecture false. So a counterexample is a specific case for which the conjecture is false. That is very important. So hit pause and write down these three definitions. All right, so let's go through the process and see a pattern here. So describe a visual pattern. Describe how to sketch the fourth figure in this pattern and then sketch the fourth figure. So notice the first, second, and third figures. And we're going to go through stuff here. So the solution, each rectangle is divided into blank as many equal regions as the figure number. So figure number 1 is divided into how many? Figure number 2 is divided into 4, and figure number 3 is divided into 6. So how does 2 relate to 1, 4 relate to 2, and 6 relate to 3? If you thought or said twice, you are correct. Each rectangle is divided into twice as many equal regions as the figure number. Sketch the fourth region by dividing the rectangle into how many? If you said eighths, you are correct. Shade the section just below the horizontal segment at the left. So drawing this here, you would draw a rectangle here broken up into 8 regions, and you would be shading in the bottom left one. All right, take a few minutes and I would like you to continue this problem and shade in figure 5, the figure that would come after figure number 4. If you did this, you broke it up into tenths, it would look like that. All right, now let's look at a number pattern. Oh, now I don't know where it is. Hold on one second. All right, we're going to see how this goes. So here is the second page here. Let's look at a number pattern. Describe the pattern in the numbers. -1, -4, -16, -64, and ... That ... tells you that the pattern continues. Write the next 3 numbers in the pattern. So whenever I see a number pattern here, I'm always looking at, all right, what are we doing? Are we adding, subtracting, multiplying, or dividing from the first to the second? So to get from -1 to -4, we could either subtract by 3 or we can multiply by 4. So now I bring those 2 conjectures in my mind and say, all right, how do we get from -4 to -16? Well, if I subtract 3 from -4, it would be -5, -6, -7, and the next number is -16, so that one doesn't work. So I'm going to cross out subtracting 3. So let's check, can I multiply -4 by 4 and get -16? That is correct. So all of these here are the same pattern. We're multiplying every number by 4. So take a minute and I want you to multiply negative 64 by 4 and get the first one. Multiply by 4 again and get the next one. And then multiply by 4 and get the next one. So we were finding 3 numbers here. Hit pause and find what the next 3 numbers of your pattern would be. If you said negative 256, negative 1024, and negative 4096, you are correct. All right, making a conjecture. Pause and read this example here. Given 5 non-collinear points, make a conjecture about the number of ways to connect the different pairs of points. Make a table and look for a pattern. Notice your pattern in how the number of connections. Right now there's number of connections here. Let's look at our figure is 0. Number of line segments of connections is 1. This becomes 3. 1, 2, 3, 4, 5, 6. This becomes 6. And we're thinking about, all right, we're trying to figure out the number of connections for 5 here. So notice that the number of connections is increasing. So when we're increasing, we're either adding or multiplying. So to get from 0 to 1, I can't multiply, I have to be adding by 1. From 1 to 3, how many are you adding? If you said 2, you are correct. And then we're adding 3, and then so on and so on. So you can connect the 5 non-collinear points by the previous number, 6, plus 1 more than the previous number that you added by, so 4, or 10 different ways. All right, your checkpoint here. I am not going to do these with you in this video. You are going to hit pause and you are going to come up with these 2 answers. And then we will go through them next class. So hit pause and try numbers 2 and 3. All right, moving on to example number 4, making and testing a conjecture. The numbers 1, 3, and 5 are called consecutive odd. Make and test a conjecture about the sum of any 3 consecutive odd. So 1 plus 3 plus 5. 1 plus 3 is 4, 4 plus 5 is 9. 5 plus 7 plus 9. 5 plus 7 is 12. 12 plus 9 is 21. Take us a few seconds and figure out what 3 plus 5 plus 7 are, and 7 plus 9 plus 11. If you said 15 and 27, you are correct. So, looking at those numbers, 9, 15, 21, and 27, I am noticing that all 4 of them are multiples of a certain number. And that number, if you didn't even notice here, that's standing out. The book kind of gives it away here. We have this times 3. So all of them are multiples of 3. So 9 is what times 3? 9 is 3 times 3, which is right here. 15 is 5 times 3. 21 is 7 times 3. And 27 is 9 times 3. So the sum of any 3 consecutive odd numbers is 3 times what number? Where are we seeing 3, 5, 7, and 9? From the problems. 1, 3, 5. 3 is here. 3, 5, 7. 5 is right here. 5, 7, 9. 7 is right here. 7, 9, 11. So it is 3 times the second number. Now we're going to pick two completely random examples of 3 consecutive odd integers, including some negatives here, and we are going to look and say, oh, let's see if our answer will be 3 times the middle number. So, -1 plus 1 plus 3. -1 plus 1 is 0, that cancels, and then plus 3 is 3, and our middle number is 1, so 1 times 3 was 3, so that is correct, that's why there's a check mark there. 103 plus 105 plus 107. Pause and add that up. You may use a calculator. If you said 315, you are correct. And quickly, what is 315 divided by 3? 1, 0, 5. Is that the middle number? Yes, that's what there's a check mark there. Good. So our conjecture would hold true. The conjecture would be this right here. The sum of any 3 consecutive odd numbers is 3 times the middle one, the second one. All right, checkpoint here. Make and test a conjecture about the sign of the product of any 4 negative numbers. What it means by that is you are going to take 4 negative numbers and multiply them all together, and you want to know, is the answer positive or negative? So go ahead and hit pause, try a bunch of examples. For this, I would like you to test out 5 different examples. Go ahead and pause and make test a few, make a conjecture, and then give me an additional one. So you should have 6 different examples there. We will go through that tomorrow in class. All right, next one, finding a counterexample. A student is making the following conjecture about the difference of 2 numbers. Find a counterexample to disprove the student's conjecture. So his conjecture is the difference of any 2 numbers is always smaller than the larger number. So we have to try to come up with something that would disprove him. So we need to find a difference. We still have to do what they're doing. Difference of 2 numbers that when you get your answer, it is, they said smaller. He said always smaller. Very, very, very tricky not to use the word always in math. So always smaller. So that is greater. We're trying to disprove. So greater than the larger number. And your book gave you one here. 8 minus a negative 4. 8 minus a negative 4 is the same thing as 8 plus 4 minus minus. Add the opposite. And this is 12. Because 12 is not less than 8, a counterexample exists. So just by us showing this one example here, we disprove this kid, and he cannot say that word here always. So that would be the counterexample there. All right, last example. Make a conjecture from the data display. The scatter plot shows the average salary of players in the NFL since 1999. Make a conjecture based on the graph. So, in 1999, the salary was somewhere between 600,000 and 800,000 because the dollars here are in thousands. And the year after, so 2000, it went up to 800,000. And then in 2001, notice I'm just adding this number to 1999, so 2001, it went up to 1,000 thousands, so that would be a mil. And then keep going up and up and up. So looking at a pattern there, the scatter plot shows the values are doing what? Based on going across from, as the years are getting more and more, the values are going up. So we say increasing each year. So one possible conjecture is that the average player in the NFL is earning how much money in 1999? The conjecture we can say is they are making more today than they are in 1999. Let's hope so, right? All right, so to end this video here, you are going to hit pause and come up with your answers to numbers 5 and 6. I'm going to zoom out here so that you can see the graph from example number 6. So this here is talking about this graph up there. Hit pause and do the checkpoints 5 and 6. You can always go back and rewind and look at any of the checkpoints, numbers 1 through 6. Make sure you bring them to class with the answers and your work shown for credit. I hope you guys have a great day, and I will see you next class. Thanks, guys.